today? Ooh, optimization problem!
Hey, Nino here.
And maybe here! Here is our goal. Before this video ends, we need to learn how to solve optimization problems easily and with great understanding.
So what is this all about? Well, optimization in the field of mathematics is a technique in how to find the maximum and the minimum value of a function following a set of constraints. A constraint is basically the given. Now back to Manili.
As we all know, in solving word problems, the golden rule here is that we read the problem slowly and carefully. You can also draw a sketch or a diagram of a problem to be solved. Let's start with solving optimization problems. So to start with, let's have our word problem number 1. An open rectangular box with square base is to be made from 64 square feet of cardboard. What dimensions will result in a box with the largest possible volume? And for our step number 1, we need to define our values. Let x be the length and width and y the height as seen in our picture. And step 2, we need to find the perimeter of the box. Then 64, our given earlier, is equal to x squared plus 4xy, where the x squared is the surface area of the square base and the 4xy is the surface area of the 4 sides. And then we need to isolate the y. It becomes 4xy is equal to 64 minus x squared, then divided by 4x to find the y. And then it becomes y is equal to 64 minus x squared all over 4x. As for our step number 3, the volume formula. And our volume formula is x times y, which is the definition of our values earlier as seen in step 1. And then when simplified, x squared y. So that's our volume formula. Then the value y that we got earlier, then we need to substitute it to our volume formula. Then it becomes like this: x squared times 64 minus x squared all over 4x. And we need to cancel the x in x squared and 4x. So it becomes x times 64 minus x squared all over 4. Then since we can divide it, the 64 and 4, it becomes 16 here in x times 16 minus x squared over 4. Then distribute our x. So the answer is 16x minus x cubed over 4. And then for our step 5, we need to derive. Derivation. The v prime, the volume formula we had earlier, we already derived it, and the answer is 16 minus 3x squared over 4. Then, since we need to have the same denominator, so here is our product when we had to compute so that we can have the same denominator. 64 minus 3x squared all over 4. Then we need to isolate the 3/4 because we need to find our factors. 3/4 times 64 over 3 minus x squared. Then to find our factors, we have 3/4 times 8 over square root of 3 plus x times 8 over square root of 3 minus x. Then we need to equate it to 0 to find our factors. And we have here x equals 8 over square root of 3 or negative 8 over square root of 3. Since the x equals negative 8 square root of 3 is not a real value, we'll choose the x equals 8 over square root of 3. And as for our final answer, the value we got earlier, the x equals 8 over square root of 3, and the y equals 64 square root of 3 over 9. By the way, we got our y when we substituted our x in the formula we have earlier in the volume. Then the largest volume is v equals 4096 square root of 3 over 27. So the answer to our problem is this. V equals 4096 square root of 3 over 27. Easy, right?
So problem number 2 is very different from number 1. It's more hard, but I know you can do it. So car B, this one, is 30 miles directly east of car A and begins moving west at 90 miles per hour. At the same moment, car A begins moving north at 16 miles per hour. What will be the minimum distance between the cars, and at what time t does the minimum distance occur? Now, come here. So here's the idea. Wait. Okay, so here's the idea. So this is the position of the two cars, car A and car B, before tea time. And this is their position after tea time. And according to the word problem, we're going to find the distance between the two cars after tea time and the tea time as well. But first, we're going to focus on L, which is the distance. Let's say that again. So since L is a hypotenuse, we're going to use the formula of c squared is equal to a squared plus b squared, and then substitute L to c, and then x to a, and then 30 minus y to b. But why 30 minus y? Well, it's part of the triangle, of course. But where did the 30 minus y come from? It's the 30 miles distance minus the distance that y has covered. This one. You see? Ha. And we find L. The answer of L is square root of x squared plus 30 minus y squared. The next thing we're going to do is find x and y, which is distance. I said it again. I'm going to use the formula of distance is equal to rate times time. So x, the distance of car A, is equal to the rate of car A, which is 60, then times t, which is not given, and then y, this is the car B, is equals to the rate of car B, which is 90, and times t. Now we move on. The next thing we're going to do is substitute x and y to L. So what happens is L is equals to 60 t squared plus 30 minus 90 t squared. And then I'm going to simplify this one to 3600 t squared, and I'm not going to simplify this one because we're going to use it later. There we go. Next thing we're going to do is derive L. So when it comes to deriving big equations such as this, the first thing I'm going to focus is the outer one, this one first. So we're going to think of this as just one thing, and we're not going to change anything yet. So what happens is 1/2 here will go to here, and then this same as this, and then this exponent will be minus to 1, and then it will become negative 1/2 later. And then the next thing we're going to do is derive the inner part. So what happens is we're going to derive each part separately. So what's going to happen is 3600 times 2 t 2 minus raised to 2 minus 1. So
that's the derivation of this one, and then this one, which is 2 times quantity of 30 minus 90t times negative 90. We're going to simplify that, and then the answer is 23,400t minus 5,400 all over 2 square root of 3,600t squared plus 30 minus 90t squared. Catch my breath. So how to find t? Here, this is the numerator is the only way to find t, so we get that 5,400 over 23,400, and then approximately the answer is 0.23. So we have already answered the first question. Second, actually. And then the final answer. This graph is only for aesthetic appeal. Now, what happens is I'm going to substitute t to x, oh my god, x here, and then the answer will be this. And then I'm going to substitute t to y, and then this will be the value of y, and then I'm going to use x and y and then I'm going to substitute them to the formula of L, which will occurs this one, and then this will approximately be the answer.
Alright, thank you guys for listening. We hope you've learned a lot from us, from Lady B and Nino.
And I'm so sorry for the long discussion, but minus our grades.